All right, so this is 8.1. Learning about the geometric mean is the first part. So the geometric mean is the positive square roots of the products of the extremes. So your two extremes are your A and your B value on this one. So these are your extremes right here. So I can write this as A over X is equal to X over B. All this means is A is the short leg on this one. So this is the short leg. And it is the same as the short leg. Let me just go ahead and switch colors on this other triangle here. So here's this triangle. X represents that one's short leg. So that's that there. On the red one, A represents my short leg. So that's how I have this set up. Those are the same. And then, or let me just say it as short leg. We'll do short leg over long leg. So on the red, short leg is A, long leg is X. On the green, short leg is X, and my long leg is B. So X over B. Short leg over long leg. When we cross multiply these, we end up with x squared equals AB. So when we square root them, x is equal to the square root of AB. So in that case, I can multiply my A times my B and find the square root. So that'll make sense when we go down here to take a look. So to find this x value, I'm really just multiplying 2 times 50, which is 100, and I'm finding the square root. So the square root of 100 is 10. So x is going to equal 10. 10 is the short leg for this green triangle, but it is the long leg for this pink triangle here. All right, go ahead and pause it, and you can try the next one on your own. Great. So this one you had 80, the square root of 80. You're going to pull out any perfect squares. The numbers that make this are 16 and 5. So this is going to be 4 radical 5 is going to make up your x value, which is the short leg for one and the long leg for the other. We can work backwards. So we're going to use this same process to work backwards to find the long leg of this one here, or the x value for this one. So if I set it up the same way, this one's short leg to long leg ratio is 8 to 6. That is short leg to long leg. So following that same pattern, the other triangle, short leg is 6 to x, or 6 over x. When I cross multiply, I end up with 8x equals 36. Going to divide both sides by 8. And I will have 4.5. So this x value is 4.5. Good. Go ahead and try the next one on your own. All right. Welcome back. This is now x over 5 is equal to 5 over 12, or 25 is equal to 12x. When I divide by 12 on both sides, this is going to come out to 2 and 1/12. If you put that as a decimal, it is about 2.08. So either of these will work. Fraction is the more exact answer. All right. So on these ones, it's called geometric mean because we're using these bottom two numbers to find the altitude or the height of the triangle. Let's go down. So in this theorem, it actually splits our triangle up into 3 pieces. You can see here, this is kind of like the triangle we just had, where CD represents the altitude, but it also creates now 3 triangles. There's this little one here that is green. We have one over here that is pink. And then we have one that is blue here. So it actually splits that triangle up into 3 separate pieces. So I'm going to erase that so we can see. Erase it so we can see it all. Okay, so it splits it up into 3 separate pieces. making all three of these triangles similar. So if I'm identifying the pieces that go together, the hypotenuse is always across from the 90 degree. So this one's 90 degrees is here. So this one's hypotenuse is here, EG. Go ahead and erase that one for a minute. Let me switch colors. This one's 90 degrees is here, making this one its hypotenuse. And lastly, the little triangle's 90 degrees is here, making this one the hypotenuse. So it's a matter of understanding which pieces are the same. So if I'm going to write them as three separate triangles, and I'm starting with the blue one, I'm going to go short leg to long leg to hypotenuse. So the short leg is EH, F. Oops, I did not write those in the order I said. E, H, then F. That's the little triangle. Now if I go on to the red triangle, same thing. I want to go short leg, long leg, and then to the hypotenuse. So I'm going F, H, G. These are similar. And if I go to the giant one, I'm going here, short leg, long leg, hypotenuse. So that one is E, F, G. So it's just a matter of finding the ways to identify your similar triangles. Oops, let's go, keep going. So this is what I just did. I separated them into three separate triangles, and we can do that. Name their corresponding angles based on theorem 8.1. We have two other theorems, 8.2 and 8.3. I said earlier that the altitude was the height, which of this triangle here, and we can find it using the geometric mean. It would just be the square root of x times y. We set it up using the two ratios earlier, but you can also just multiply those two to find the square root of it to find the height. The geometric mean leg theorem is just based on the things that you know. C over B, so C is the hypotenuse over the short leg, is the same as B over X, because for this one, it's also the hypotenuse over the short leg. So it looks just like that. And you do it the same way, cross multiply, and then you can find the square root to finish solving that. So let's scroll down and take a look here. To start with, we're just going to write it out, our sides. So if for example, I'm going to have the triangle oops, let me go back. Let's go WXY. Let's start with the big one, WXY. I want short leg to long leg, so WXY. So if I'm going on the little triangle, that would be short leg to long leg. It would be WZX. And if I go on my last one, short leg to long leg, it would be XZY. It's just naming the pieces that are the same. We want short leg to long leg. So all the pieces would be the same. If I did short leg over long leg on one triangle, that would be short leg over long leg on another triangle. So I could set up the ratio to find the similarity between the two things. If I was doing that, that would mean that WZ over XZ, so WZ over XZ, that is my short leg, long leg, and then I would want it to be the equivalent to the other triangle, short leg over long leg. So that could be WX, because if I'm doing this big one, WX over XY. Just making sure my pieces match. I can do hypotenuse over short leg equals hypotenuse over short leg as well. So we can use these patterns to solve for the missing pieces. So let's go ahead. We're going to do this first one together. finding the missing pieces. The easiest one for us to start with is we know how to find the altitude or the y because it's the geometric mean. It means I'm multiplying 3 times 12, which is 36, and the square root of 36 is 6. So that makes this one here. We use this finding the geometric mean. It could also have written it as y, which is the long leg over the short leg, y over 3 is equal to the long leg over the short leg of the other one. So 12 over y. And when we solve for this one, we would have got 36 equals y squared. That's where I got that 6 from. I'm going to go ahead and write a different color. 6. So my y equals 6. Now I'm ready to solve for the other ones. Let's go ahead and solve for x right now. Oops, let me get my pen color. So for x, I'm going to do my hypotenuse over my short leg. So my hypotenuse is x on this one, because that's what I'm solving for. And the short leg of that one is 3. Now I just need to have another one that I have the hypotenuse for. I have the hypotenuse for this big one here, so I'm going to use that one, which is 15, over that one's short leg, which also is x. So I end up with x squared is equal to 45. And when I simplify, square root both sides and simplify, I'm going to end up with 3 radical 5. All right, let's go on to the last one. For this one, I'm going to go ahead and erase everything we have on there so far. And let's go with, I'm going to do my long leg. Because I'm solving for z, this is a long leg on this one. It is also a hypotenuse on this one. So I want to use long leg and hypotenuse. Long leg over hypotenuse. So of this triangle, my long leg is z over my hypotenuse, which is 3 plus 12, which is 15, is equal to what is my long leg on this one, 12, over my hypotenuse, which is z. So I have z squared is equal to 180. When I square both sides and simplify, I get 6 radical 5. So the key to this is to choose the variable you're solving for and then see what it represents. So I'm going to start this next one here. So if I was solving for E, it is a short leg for this one here, this purple one. It is a short leg. It is also a long leg if I'm doing this little triangle here. So it's a short leg and it's a long leg. So I'm going to do short leg over long leg. For the short leg, for the purple one, it is an E over its long leg, it's 24. Then for the little one, the short leg is 6 and the long leg is E. So when I cross multiply, I get E squared is equal to 24 times 6, 12, 24, carry 6, 12, 144. When I square both sides, E is going to equal 12. So that means this will equal 12. Now if I want to figure out the other sides, I'm setting it up. I'm going to go ahead and erase all of that so I don't get confused. Put that 12 back in. When I'm ready to figure out C, I'm going to solve for C. This is a long leg on the big one. So C has a long leg. It also represents a hypotenuse. So I'm going to do long leg and a hypotenuse for this one. So the long leg for this one is C, and the hypotenuse for that big triangle is 6 and 24, which makes 30. And then I'm going to do another triangle. The other triangle I have has the hypotenuse of C and has the long leg of 24. So is equal to 24 over C. Go ahead and cross multiply and finish solving there. I'm going to move down. Go ahead and pause if you would like and finish this problem. You can also solve for D. Okay. If you just came back, you're going to scroll down. This is the first one I did. We multiplied 6 times 24. our second one, we had the square root of 180. And then the last one we had, so here were our numbers, 12, 13.4 approximately, and 26.8 approximately. You can go, if you put this in slow motion, you can see the math above. We're going to do one more of these together, and then I'm going to have you try the ones below. So again, solving for x, which is here, this represents a short leg on my big one. It also represents a hypotenuse on this little one here. So it's a short leg and it's a hypotenuse. So that's one of them. So I'm going to go on to my y and say the things that y represents. Y is here. It represents a long leg and part of a hypotenuse. So I have a long leg and I have part of a hypotenuse, meaning the hypotenuse for that one would be 6 plus y would create the hypotenuse for the next one. And the long leg for that one would be z. So let's check out what z is going to be. Z represents a hypotenuse and also a long leg. Okay, so for this one, we know that, let's start with x, where we're the short leg over the hypotenuse. The short leg was 6 on this little one here. I'm going to write it underneath so I have more space. Short leg was 6. Its hypotenuse was x. That represented this little triangle here. Now we're going to do the other triangle that has x represents the short leg. And now its hypotenuse, so that was this one, its hypotenuse is this here, which is 6 plus y. All right. And then for this one here, solving for y, I'm going to go back. I'm going to do this one a little bit different. Since we did the 6 plus y for our x value, let's, for our y value, do a different one. For our y, let's do a short leg over a long leg, since we have more of that information. So the short leg, so the y is here. That represents the long leg of that one, but the short leg is 8. So 8 over y is one of them. And then I could use this short leg and this long leg because I have both those measurements. So the short leg is 6 over 6 over 8. And so I multiply my two 8s. I got 64 equals 6y. I'm going to go ahead and divide by 6, and y is going to equal 32 over 3. I can then go back and use this one for here. 32 over 3 is the equivalent of 10 and 2/3. So if I add 10 and 2/3 to this one, this is 16 and 2/3. That's what I'm going to end up using. So we had to solve for our y before we could find out what our x was going to be. For solving for z, I set up the hypotenuse in the long leg, but we're going to go ahead and change that. Let's set it one for easier. So the reason I'm going back and changing these is because we have givens, like 6 and 8 is a short leg and a long leg, and those are given to us, so it makes it even easier for us. So let's use what is given to us. So for z, this represents a long leg, so we can do a long leg. So let's go ahead and do the long leg, and if we were to go back and solve x here, we'll have a short leg. So let's go ahead and solve x. So 6 times, this is the equivalent of 50 over 3. So when I multiply straight across, this is going to be 100 equals x squared. When I square root it, x equals 10. So that's going to represent what this is here. And now I can go back and do long leg over short leg. So long leg for this one is z for that big one, and the short leg is 10. And then for this other little triangle, which we're using a lot because it's got two givens for us, we're going to have 8 over 6. That's going to make 80 is equal to 6z. When I divide by 6, it's 40 over 3. And then if I want to make that into a mixed number, that is going to make 13 1/3. All right, go ahead and give these other few a try. Pause and give them a try on your own. This one here first. I think it's our last one. Yeah, go ahead and give that one a try on your own. All right, welcome back. Let's do this one. So for this one, solving for x, I set it up as a short leg over hypotenuse because here's a short leg and here is a hypotenuse, but x also represents a short leg on the big one, and I can see the whole hypotenuse. So I'm just looking at 5, 20, and x for my possible numbers I could use. So I'm going to do short leg over hypotenuse. So the short leg of this one is 5 over the little one, which is x, is equal to the short leg of the big triangle is x over its hypotenuse, which is 5 plus 20, so 25. This is going to leave me with x squared is equal to 125. Square root on both sides is going to give me 5 radical 5. Let's go take a look at the y now. Solving for the y, this is the geometric mean. You can just remember, we can set it up short leg, long leg, but we can also remember that to find the geometric mean, which just means I'm finding the height or the altitude here, it's really these two numbers multiplied and the square root of them. So 5 times 20, the square root of 5 times 20, the square root of 5 times 20 is the square root of 100, which makes the height, or my y value, or my altitude, 10. All right. And then let's go ahead and look at our last one, which is solving for z. And I'm going to go ahead and write this one was 10 and this was 5 radical 5. I like that this one is a whole number, so it lets me, if I need to use it to solve later, it's easier for me to use than a 5 radical 5. But I don't think I'm going to actually need it for this one. I'm going to do a long leg over a hypotenuse. And I'm choosing that because that's what z represents. It represents a long leg here, and it represents a hypotenuse. So it gives me z on the top, and it gives me a z on the bottom. So this is long leg over hypotenuse. This long leg is z. Its hypotenuse is 20 plus 5, so 25. And then the other one is the long leg of 20 over z, which is its hypotenuse. When I multiply those out, it's z squared equals 500. When I simplify that, that becomes 10 radical 5 when I square both sides. All right, that is the end of the lesson. I will post some homework to match this. All right, good luck.